Morning all. So the first session for today, first education session, is navigating thermal compliance. And both Jonathan and Taylor were good enough to send me bios. And seeing that they came from clear across the country, it's only fair that I take a minute to actually read those and let you know let you know who's speaking today. So Jonathon, known as Jomo, which I didn't know until I saw this. You'll have to explain that. Has been with Layton Consulting Team since 2011 and the CEO since 2018. His background in the fenestration industry came at a young age as his late father, professional engineer Mark Layton, founded the company in '94. Growing up with engineering in the home influenced Jonathon to pursue his studies. However, he discovered his true passion was working with people, pragmatic problem solving, and business strategy. Following his initial education, Jonathon went on to pursue his MBA, which was instrumental to his efforts in carrying the company through the sudden loss of Mark in 2015. Jonathon is actively involved in Layton's thermal modeling initiatives, both as an NFRC certified simulator and as a member of NFRC's Marcom network. Jonathon enjoys public speaking, done several presentations to the fenestration community, city officials, and other business societies and associations. While at home, he enjoys being a silly dad with his 3 kids, riding his motorcycle with his wife, and building Lego. And Taylor Wight also is with Layton. He's been part of the Layton Consulting Team since 2017. As a mechanical engineer, he quickly became a leader in the fenestration thermal simulation and heads Layton Consulting's NFRC certified simulation lab. Taylor finds satisfaction in streamlining processes, plays a key role on the executive committee of Alberta's Glazing Association, PGAA and GAMA. He's also actively involved in NFRC's several subcommittees and task groups. Outside of work, Taylor recently moved to an acreage in southern Alberta near the Rockies where he enjoys hiking, biking, campfires with his 3 kids. The last time he was in PEI, he was just finishing off a cycling trip across Canada. Impressive. So welcome, Jonathon and Taylor. And I understand a late entry, John Hill, we're going to hear from as well from Keystone. All right.
Thanks, Terry, and thanks, everyone. We're really excited to be here. As long as my laptop doesn't decide to time out, we'll get through this pretty quick. So yeah, thank you. And as I said, Jonathon Jomo, it's my childhood nickname when I used to play rugby. Jonathan's just kind of too long of a name to shout out when they're like, go kill him. And we have another Jonathon in the office, so it gets really interesting when someone calls and they're just like, hey, Jonathon, I need blah, 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 blah. I'm like, whoa, you want the PN? I'll transfer you over. So it makes it a lot easier. So those who know me well and get to know me, I just say Jomo, and feel free to call me that. And yeah, Taylor, pretty impressive with biking across Canada. Yeah, he plays it down, but in reality, he used to bike with Lance Armstrong until he got caught doping. So it's, yeah. We'll never know. No. So as Terry mentioned, I can't pass up the opportunity to share that company started 28 years ago. That's my dad there. He suddenly passed away in 2015, and it was tough for us to figure out how we were going to adjust, but got down, grabbed a couple engineers from different industries and said, we have a great industry that we're in. We have great values that my dad started, being a pragmatic engineer, wanting to just figure out how to make things work for the client. In a very direct way, we get paid when you get paid, so we got to get this done. And he specialized in especially structural engineering. That was pretty much his background. And he had licenses all over Canada and the US, and it took us a long time to get kind of back to that stage. And so most provinces and states were able to stamp off things. And also we consult all over the world. We've done projects in Malaysia, over in Asia, China. We did a science facility that was built in Asia, but then it was installed in Antarctica, and have done a few things in Europe. And my favorite one, because I got to be the one to go do it, was the FIFA soccer stadium. I got to pick the name, Arena Comboter in Tirana, Albania. So this is a curtain wall that actually has these cantilevered, prism cylinder things that kind of like move in the wind a little bit. It's a really cool design. It was a really fun opportunity, and we're actually still doing projects over there. So we're very well known for our engineering side, but We've also been involved in the, on the engineering side. So we're checking, as any great competent engineer specializes in glass, they know they're going to look for live loads, they're going to look at dead loads, different code requirements, glass types, thicknesses. We do site reviews for installation completion, and we can provide schedules, letters of assurance, whatever's needed to get that project actually done. This one's going to go. I'm not sure what to point at. Still working? No, there we go. So yeah, just to give some timeline, what qualifies us to actually speak on thermal modeling. So we were founded in 94. In 2009, we actually got our first inquiry from someone trying to complete a project in the city of Vancouver. Like, hey, I've got this like weird thermal requirement. You guys ever heard of that? And it led to one of my partners, Ivan Chu, learning about NFRC, calling up NFRC and saying like, what is this thermal thing? He went down to Minnesota, got trained, and that's kind of how it started. Today we have actually 6 staff, one in Germany, Taylor, who's located in Alberta, and the rest of us in the Lower Mainland, who are certified thermal modelers with NFRC. And then last year in December, we got the thumbs up from NFRC that we are now a certified simulation laboratory. And one thing that I've noticed, especially in thermal, which actually isn't unheard of. I mean, like if you look at the window industry as a whole, we've all heard people say like, well, we did this 20 years ago, or that's how we've done it for years. Like obviously those days are done. You know, we've seen increased industry requirements for guards, structural loads. You know, NAFS was adopted by the National Building Code of Canada in 2010. Energy performance, both products and the whole building have all kind of increased over the years. Not to mention all the initiatives like LEED and Passive House and Step Code and all the other things you've heard. So this like understanding that there is a continual progression to have compliance to stuff is not new. It's just that thermal kind of seems more of a newer thing. And on the West Coast, where there's really this drive to be, you know, the greenest city in the world in Vancouver, greenest province in Canada, greenest country in the world, it's trying to push everyone to be more energy efficient, but the struggle is we want like this fast way to do it. Like just tell me how to do it and I'll do it. Like I don't really think our industry is like fraudulent. I mean, sure there are, or anyone's like trying to be sneaky. It's just that there's so much and we're just so fast paced that it's like, just tell me what to do, I'll do that. And as much as the cities or especially Vancouver or other compliance are like, well, just do this. It's kind of this disconnect in information. And so that's where we want to come in. And I compared it to the Autobahn because when I was in that project in Albania, everyone told me, oh, go on the Autobahn, you're going to love it. And sadly, I can't drive stick shift. I tried while I was in Switzerland, and I found out that Swiss people are super nice until you stop on the highway and you stall a car several times. So it made a bunch of Swiss people really mad. But the guy I was with, we took our rental car and we got up to 200 kilometers, and I was like, okay, I'm good. You can slow it down. But we had people passing us, no problem. And I was like, man, the Autobahn is amazing. Like you could just fly. But I didn't realize how it was amazing until we had to go to a city that was off the Autobahn, and that was Ulm. We went to a glass supplier there, and they, as the crow flies, were about an hour away from where we got off. But because of the way Germany's broken up with different districts and farms, you like do this crazy roundabout. You have these, you'll see the road you're trying to get to, you know, and it's not very far, but you've got to go like this huge around this farm and then back. And you're like, why can't we just go through? And it took us almost 3 hours to get to this place. And it amazed me how different and how the Autobahn was built must have been just like, finally we have that. So we're trying to give a little bit of that and stop this like flooding of city officials, inspectors, even clients, or if you're selling your product to people, of paperwork to just like, here, yeah, it passes. Like everything passes. Sure, it's fine. And that's what we see a lot. A lot of confusion on both ends. We'll have end users, customers come to us, say, you know, is this really true? We'll have window suppliers come to us who have bought certain product and like, how do I know this is correct? And then city officials, we're asked many times to comment on thermal values that are provided. And sad to say, there's a significant number that aren't correct or aren't reporting what's required. Or even when we double check it, we know kind of from seeing it that it's not correct. And there's no one to like blame. I'm not like, oh, these guys are the worst. It's just, they're just so like, how do I do this? They're overwhelmed. So that's kind of what we want to talk about. First, understand that there's no easy Audubon. Like, I'm not going to be here and be like, okay, do this. You're flying, but there is efficient way to get this done. So, and like I was saying, I know that we feel overwhelmed. There's so many different initiatives that it's like, where do I even start? If someone says, I want this to be a passive house, and make sure, I've seen spec writing, make sure it's this solar heat gain and this U value, and it's like not a possible thing to accomplish. Energy Star, you're like, that's what I want to do, but how do I get my ratings? This is from Europe. I mean, it's so convoluted that none of you actually noticed that was actually a marijuana organization. So I know we're just overwhelmed with it. And Taylor actually had a really good analogy when we started talking, how do we want to frame this? He said, it reminds me of Alice in Wonderland when we're talking to some people. It's like, I don't even know where I want to go at the end. I just know I got to be thermal compliant. And it's almost like, well, it doesn't matter where you start if you don't know where you want to go. So we're just trying to start right from the beginning to help people out, to really frame it around like just this drive on the Audubon. And there's different paths to go. We're going to get to a few different destinations, but on all of them, there's some common checkpoints. So everybody is going to kind of play in the same field at the same point. So and some of you, this is going to be new. Some of you, this is old hat stuff. So I just wanted to take a look under the hood. Like, what is the NFRC engine? Why do we call it NFRC? The National Fenestration Rating Council, and what is it really giving? So everyone has seen these stickers before, whether on your windows, you've seen them at projects, or you're putting head labels and put on for yourselves. As you see, the U factor is, the U factor and the solar heat gain, those are the primary energy performance ratings. So any system that's sold or installed in Canada should have that information. Some of them are going to have additional performance ratings. Some will have all these, some of these. But when I look at it from like our analogy here, the U factor is like the engine, and the solar heat gain coefficient is like the transmission. It doesn't really matter if you get these things. You can, it is faint. Yeah, you can be excited about all the other stuff, but if your engine and your transmission aren't working properly, it's like, great, I'm not going anywhere. And for the purpose of today, because U factor is kind of seen as the primary and often the thing that we're asked for the most of how do I prove this is energy efficient? That's where I'm at today. So what's the U factor anyway? Well, NFRC gives this definition. It measures how well a product can keep heat from escaping from the inside of a room. The lower the number, the better a product is at keeping heat in. Like, okay, cool. And there's this, somewhere unrelated, I found this little graphic, and I've been guilty of this before myself, of looking at this and just saying like, okay, double or single glaze, that was bad UVal. Then we went to double glaze. Then we applied a low E coating. And you kind of start in your mind thinking of it as a filter. Like if we just put more glass, more low E coatings, it's just going to get lower and lower. But it's actually not entirely accurate, because on how it's reported or represented is watts per meter squared Kelvin and the BTU for the imperial. So up in Canada, we're using that. And watts and per hour, watts is joules per second. It's actually a rate at which that heat is lost from inside. So to think of it, it's I'm on the right side. Yeah, the energy performance, all energy performance related to conduction, convection, and the radiation. But the U factor is the rate at which this happens over time. Looking for lower numbers can be seen as lower equals slower. So the lower the number, the slower you're going to have that heat loss. That's why we're like, yeah, get that number down. To put it in like a complicated, but it makes sense to me way, it's the heat transfer per amount of time, per area, per degree of temperature difference. So you have those three components of it, but it's a rate at which it happens. So the filter idea, it's a good way to think about it and also to present it to people, but it's not entirely correct. So here we are. Why NFRC? Well, long before my time, if you had a product and you want to sell it and you're like, hey, this is rated, don't worry about it. Anytime you changed any little thing, there's a new test. And tests sometimes weren't all comparative. And it led to some people just being confused and frustrated, throwing their hands up, maybe even just kind of ignoring, well, I don't have to do it over there, so I sell these windows here. Why the heck am I even doing that? I'm not even going to play in that field. And unfortunately, the people who really suffered were the end user, the end consumer. They had no idea which was a better window. I mean, I look at this and I say, just from these two windows, company ABC, XYZ, which is a better window? I mean, just one's bigger than the other. Can I prove by any way? Are they the same window? Am I comparing apples to apples? 'Cause I don't know what the frame looks like. I don't know what the glass difference is. And I've seen, hilariously, some really old reports of like giant IGU units, and that's the reported U value for a window. So it has nothing to do with the frame. And then someone else who's got like actual, they tried their best to come up with, they had the rated size. And I'm like, no wonder that guy's business went out from under. Like, he couldn't compete. And he's just trying to be like, yeah, this is something the rated size I want to stick to. So NFRC really came out to benefit both our industry, to be able to compare apples to apples, and the end user to be able to make that best choice of what's the best window. The CSA requirement A440.2 and NFRC are harmonized. There's an extra step, which John will talk about for US, but all the sizes were made standard. And in order to get energy values, we use the modeling software that NFRC has called Therm and Window. Anyone can download it. People can go and learn how to do it. To be certified, you actually have to go, well, they did Zoom over COVID. But we all go to Minnesota, we do training once a year, we do a test. Also as a lab, we do another test. So we're always kind of being vetted that we're doing it appropriately, because material properties change. Some modeling things have changed over years. So there's things you have to keep up to make sure that it's accurate. And as I said, there's these standardized sizes, and these have also changed over time. CSA was slower to adopt a dual action window than NFRC. So when we're comparing everything, like a tilt and turn. So, no matter what your product is, if it's rated or it's been modeled, it's to this size when it's under the NFRC or CSA. And the U factor is used to answer that question, like how energy efficient are my windows based on these sizes. So just to get your breakdown on how a U factor is calculated. So each product consists of 3 different U values. Essentially, you have the center of glass, which is going to be your best performing. That's like when someone, has a double glaze with a single low E. The next thing to adjust to try and get the biggest bang for your buck is an interior low E, or going to triple glazed. That being the lowest is always going to perform better than your frame. And I say that always. Maybe one day I'll be wrong, but as of yet, I've never seen a frame outperform an IGU. And then there's this edge difference and the frame, as I was saying, was the worst performing area. And so there's this, in general, this 2.5 inches where it's this like mixing of the poor and the better. And all those go into a final U value number, and each side of this frame. So you'd have one of these models for the head, both jambs, and the sill. And as I said, it's had to be sized to a standard size, because the U factor is a ratio, like it's influence of glass to frame. So if you had a huge window, it will inevitably perform better than one that's smaller. So just to show you the math behind that, so essentially explaining what I have, this one actually has a true divider, so you would have more models in it rather than just the 4, but it's the same thing. You've got the frame, the edge, the center of glass, and that's U value total over the area of each part. So it's kind of like an area weighted average of each component to a standard size. And then this is just to show you as well, we just took a random fixed window. The standard size is a width of 1,200 millimeters. And we just said, okay, what if the width's really small? What's our U value? And so you can see that you kind of have the smaller it is, the worse it is. And as it comes down, it gets better and better because that ratio increases. But everybody who's reporting on a frame, they would be somewhere on just that 1,200 line. So that's the standard size. That make sense? Yeah? All right. Oh, is there a way to get rid of like the little thing? If not, it's okay. It's all good. Oh, there we go. Okay, it disappeared. So, like I said, we wanted to talk about those common checkpoints. And so really it is thermal modeling software is to be used for all products sold and installed in Canada and the US. That's where we start. If we want to give both our end users what we say we're giving, if we want code officials, we want city municipalities to just continue to let us to sell our products. If we want to sell a better manufactured piece to window suppliers, maybe you're a supplier of a component or you're a supplier of frames and stuff, all this stuff can be modeled previously to even accepting a project. And that's what we see every day in Vancouver and in British Columbia. So the nice part is it validates that thermal performance. It fairly compares between products of the same type, and it's recognized by everybody, really. And I know exactly what I'm looking at. Architects are starting to understand what they're looking for. And the governing and regulatory bodies are really asking for these values. There we go. So some of the dangers we get into. I've lost the notes. All right. The alternative modeling methods. So when I went back to like some of that confusion, so I put HOT 2000 in here. HOT 2000 is not a reporting, but it still catches me off guard. I'm dealing with a project right now when an architect says to me, well, I've got the U values, don't worry about it, gives me a HOT 2000 report. Like, this has just been selected by an energy modeler. Like, this isn't representative of anything of what you're putting in. But he was convinced that was the windows that he was getting. There's other energy rating software. There's stuff that exists. I don't know the names of all of them, but I've seen people use things. Some are fairly accurate to what we see, but they're not consistent, nor are they validated. I see a lot of manufacturers like dynamic Excel spreadsheets where they can have a customer or a consumer pick the frame, pick the glass, and it spits out a U value. That's a great place to start. But because of that need for validation, and it's sometimes quite accurate, but it should be seen as like an estimating tool, especially if you're going to sell a product. Like, okay, I don't have time to necessarily look through everything I have, but I want to know, like, am I going to get there? Am I going to pass? And if the threshold number is 1.4 and you use the spreadsheet and you're getting back a 1.2, you're like, hey, no problem. I'm good. I know where I'm going. So Taylor's actually a Passive House consultant. So I'll turn it over to you for the European stuff, buddy.
Thanks, John.
There you go.
Thank you. Yeah, so John's given a really good overview of the North American way, the methodology of calculating U value. That's not the only standard way of calculating U value in the world. As many of you know, there's the European way. Passive House is probably the most common. And many of you have probably been approached or talked about how people have said, oh, their U values are way better, or I have to import from Europe, or whatever, and they're just not the same. I guess is what we want to get to. It's not an apples to apples comparison, and we're just going to touch on this briefly. RDH, Building Science, actually, Robert LePage, Daniel Holland, I'm sure many others at RDH have worked extensively on this and have given some really good presentations. And we just wanted to go over some of the material that they shared, and just wanted to give credit where credit's due there. So to touch on a few of the differences, one is their temperature difference from outside to inside is different. So with NFRC, the outside temperature is modeled to be 18 degrees Celsius. The inside, negative 18 degrees. Yes, thank you. And then the inside is the 21 degrees Celsius. In Europe, it's a different temperature differential. It's either 0 or negative 10. There's nuances there. Just so you know that's one difference. The standard sizes, as Jomo talked about, each window type has a standard size here in NFRC. They also have a standard size in Europe. They do not always match up. That would be a nice thing to harmonize, but it's So obviously when you have bigger windows, which oftentimes over in Europe, their standard sizes are larger, it makes it easier to get a lower U value, a better U value. The air gaps, you might notice in Europe, their IGUs seem to be a lot wider, bigger air gaps in between. And it all comes down to how they calculate their center of glass U values. They follow a different standard. And so as you can see from these charts, NFRC hits its sweet spot for double glaze. It's around a 1/2 inch. Passive house, they can get a lot lower values, or lower U factors if they continue on widening that gap a little more, and they can get much lower there. So before they bottom out at that sweet spot. So that's the point where we like to hit for double glaze in North America. And then John talked about the 3 main areas with NFRC. You have the frame area, the edge area, and then the center of glass area. Passive house is different. They have the frame area and they have the center of glass area, but those aren't necessarily calculated the same. And then as far as the edge value for that transition area, they have a different linear value. So it's not actually an area. They call it a psi value. Another difference is the solar heat gain coefficient. NFRC, they take into account the energy that's passed from the solar heat gain through the frame, and Passive House doesn't really touch that in their calculations. So all kinds of differences. And all that is really to say, aside from the fact that we both call it a U value or U factor at the end of the day, they just are not equivalent. And the RDH has this nice chart, and they compared these 3 different frames with a couple different glass types, and ran the calculations using both NFRC and Passive House standards to see what the difference would be. And we kind of expected, because what we've seen is generally Passive House, they report lower numbers, so better U values, but then when we model in NFRC, it jumps up a bit. Which is often disappointing for people who are importing over from Europe, and then they find out, oh, their windows aren't that amazing. But looking at different windows, more standard North American windows and standard European windows, they found that there's a difference both in the positive and negative direction. So it's hard to say which way it will go, but they came up with up to 18% differences, and that's, we typically see around 10% difference, but it can fluctuate between 10 to 20% difference in U factors. And it's not better or worse. It's kind of like what my mom used to say. She summarized this very well when she said, Taylor, you're not better or worse than the other kids. You're just different, So yeah, that's how you can look at Passive House and NFRC. And for the rest of this, we'll be focusing on the North American standard, NFRC, as well as CSA, and that's what's relevant over here. But we just wanted to touch on that for you. So let's take a little pit stop to really. We could talk on this a fair bit, but we wanted to bring in the real experts. And John at Keystone, they've been in the industry a lot longer than we have, and they're IAs, so they look at all the modeling that comes in and all the tests that come in, and they certify those tests and modeling that come in, so they really know what they're talking about when it comes to NFRC and CSA standards. So John, I'll hand it over to you. I appreciate you coming in and joining us for this.
Thank you. And thank both you guys for the opportunity to just walk through a few slides together about this common checkpoint along our highway to compliance, and that is third-party certification. And all of these programs that are becoming more and more important to fenestration manufacturers in Canada are qualified by third-party certification. So what is third-party certification? It's an independent company that evaluates the reports, makes sure everything is done properly in accordance with the standard, and then certifications are issued. The ability to use the certification labeling is granted, and the labels go on the windows, indicate the ratings and compliance with requirements. I do want to say though, we get a lot of calls and people have this misconception that because they have their products rated and certified, that they meet the Energy Star requirement or they meet the Greener Homes Initiative requirements. These rating standards come up with the amount of heat flow, the U factor, and the solar heat gain. But that doesn't mean you make the requirements established by Energy Star or Greener Homes or building codes, things like that. So, getting it rated, then you have to have the right performance level. And, oftentimes these newer programs are requiring triple glazed products with, double OE, to get the requirement, meet the requirement, but how you demonstrate it is a certification piece. So certification bodies have to live with very stringent requirements. We all have to be accredited. Here in Canada, it's the Standards Council of Canada. And we all have certain, guidelines that we have to do. But essentially, we are verifying that on an ongoing way that the products are manufactured the way they're rated. And that includes annual visits to the manufacturing plant. There's quality control requirements. You have to be able to demonstrate that you make the windows the way they're rated. So that's a big piece of third-party certification. Now, there are actually two different methods here in Canada, two different reference standards for rating your products. And of course, those ratings are the basis of the certifications. First is the Csa A440.2, and it's very similar to the NFRC standards, and we'll get into that in a minute, but it's simpler, less expensive, and but it's only applicable for products sold in Canada. So if you need to sell your products in the US and Canada, you would then have to get your products certified, excuse me, to NFRC standards. Okay, so one or the other, depending on your marketplace. Okay, so I put a slide together to sort of contrast the two standards, and in the case of the CSA, of course, it's qualifies your products, or your products are rated for qualification in Canada only. Nice thing about the CSA method, it's all based on a computer simulation, so you can have literally hundreds of different configurations of your product, and they all get rated using a computer program. Products are requalified based on the requirements of the CB. It may be a given period of time, or it could be, as in Keystone's case, we certify products to the version of the standard for as long as it's of value to the manufacturer. So there is no real expiration date to those certifications. And then the last column here, I listed the sources. There's actually 6 different certification bodies certifying fenestration products to the CSA standard, and they're all listed there, including Keystone certifications. Now, if we contrast that to the NFRC standard, of course, again, if you need to qualify your products for both markets, Canada and the US, you'll need to use NFRC, rate your products using the NFRC method, and that now requires something in addition to the simulation called a validation test. And that does make rating the products significantly more expensive, because now you have to build a physical unit that goes to a laboratory, gets tested, has to match up with the simulated values, somewhat more complicated and somewhat more expensive process in getting your products rated. So the NFRC has a 5-year requalification requirement. So every 5 years you have to redo the simulation and testing again. Of course, on this, NFRC is the certification body, but they have what they call inspection agencies, and there are 4 of them in North America listed there, including Keystone certifications. So if you're only qualifying your product for Canada, either as a manufacturer that needs to qualify their products for these programs, or an extruder that wants to qualify their products designs for their fabricators, the CSA is a nice option and significantly less expensive, but only if you don't have to qualify the products for the US. Okay. Just one last slide. The way that the certification labels, you apply them in the factory and they go out the door with the product, and they sort of qualify. They take their qualification with them. So a building official or a building owner or a architect can see, on the products being installed that, the ratings and be able to verify they are in compliance with whatever the requirements are. So that's it. I'm going to give it back to you guys, and appreciate the opportunity.
You bet, John. Thank you. You guys want to give him a round of applause? Yeah, we appreciate that, John. And they can really articulate that a lot more clearly than we can. So we do like the analogy going along with the car analogy that the stickers on your windows are a lot like the stickers that you might get for a toll road, where you can pay for a toll pass, and then you just put the sticker on your windshield, and then you don't have to stop at the toll road entrance. You can just fly by and you're good to go. And that's a lot how certification works. Is you get those stickers, you can prove that those you have done the work, you've proven up front that those are the values that your numbers are getting, and you're off to the races. So as far as we've spent a lot of time talking about the methodology of how to calculate U factors, and as we've touched on, NFRC and CSA, they're very harmonized. CSA is a little lighter as far as cost-wise, but it's restricted to Canada. And then there's also the ISO 10077. That's the European side of things, which relates to passive house. But those are the methodology that we follow. Now, the methodology leads into the different requirements. So once these guys figured out a methodology, then the code writers realized, oh, we can write this into code. We can create standards and requirements and hold you guys to these standards. So there are many different codes, and we're going to get into that a little bit. The main ones that municipal and provincial codes are written around are, the ASHRAE standard, there's the National Building Code, the NBC, and then the National Energy Code of Canada for buildings, the NECB. And then you have, aside from that, on the other side of things, you have sort of the incentives, the going above and beyond the base requirements, and that covers Energy Star, other grants and incentives. They have different requirements that that your clients might want to meet. So they might want to ask for a better U value than the actual standard requires. And passive house, we would put that in there as well, because lots of people want to shoot for a passive house standard house, and then they would have to go a different route, a different methodology for certification. But we clump that in with the rest. So all of that leads to, provincial and municipal building codes. And then if it's a larger project, or some projects, they have project specifications, or they, specialty homes, they might ask for different things. So that's what you end up with in the end. And sometimes you might not know exactly what U factor the target is at that point. So let's get into that. So it would be nice if, all codes required the same U factor. It would make our lives, it would probably put us out of a job, actually, but it would be a lot simpler. And this chart, I put this in there because I know everyone loves looking at charts on slideshows, but this chart could be like 5 times wider. There's like so many standards. So this is just 1 year of each of these standards. As you know, each standard gets updated every 4 or 5 years, and especially recently, the standards have been becoming more stringent in U factors. So the U factors have been going down and down to hold you to a higher standard with your windows. So as you can see, they're not all the same U factor requirement based on the climate zone that the project is located in. So I'm sure all of you are familiar with heating degree days. So depending on where you are in the country, how north you are, the more far north, as you can see from the standards, the higher quality windows you need to have, which kind of makes sense, because the temperature differential is more extreme, so you want more insulation in your windows. There's a lot of other things I could go into there, but that's all I want to say about that. So aside from climate zone, you also have different adoption rates within the provinces, and that is very different across the country. A coworker was joking that, these are very fitting for Pride Month this month, because they're very colorful, all different. Every province is kind of doing their own thing with the codes, and they're at different rates of adoption. What was that? I think New Brunswick just adopted the National Building Code NECB 2011, just in 2021, right? And then you got different. I think on Ontario, Ontario is already talking about adopting the NBC 2020, and they have like a tiered system. So you have different tiers within the code that you're required to meet. So after seeing all this, I'm sure it's much more clear now exactly what U factor you need to be. So we shared this mostly just to give you an understanding. I've definitely had times where, I find it frustrating that the spec writers and architects, they actually don't know what U factor they want many times. And so to give you some sort of appreciation that, when the architect says jump and you say how high, and they actually don't know, then then this is why. So, so going off of that, just to make things simpler here, these are these are more diagrams from the codes. Just to say, okay, if you have a window and it doesn't meet our designated requirements, what do you do in that point? Luckily, they do have some understanding that, you know, these cases might arise, as I'm sure you guys have come up with. So obviously the best path is everyone has stickers on their windows. All the windows meet the required targets, and you're good to go. You're cruising in the fast lane on the Autobahn. You just cruise on by, and they don't ask any questions. If, say, for instance, you have one window out of all the windows you want to install, and it doesn't meet the specified requirement, what do you do then? Then they have different trade-off methods, and we'll get into that a little more. And then there's also a performance rating path, and this is where you get really into the nitty-gritty for that specific project and go into a detailed calculation, so you know exactly what the windows are performing at for that particular project. So if we look at this as different lanes, there's the prescriptive path, as we talked about. That's the sticker on your windshield. You just keep cruising in the fast lane, the Autobahn. There's a sticker. Then there's the trade-off path. So let's talk about that. So there's many different ways that they talk about calculating this, and I'm not going to get into all the different ways because, as you know, there's a few codes and they all have their own particular method. Sometimes you can trade off, say, for instance, a high efficiency heat exchanger for lower performing windows, or you know, better roof products for to give you a little more leniency in your windows. Things like that. Sometimes you get more points. It's like a game where you get points for having really high efficiency windows, and then they take those points and they say, well, we want to have an open car garage over here, or something where they can kind of play the game. They have, you know, the building energy modelers, they can play the game with these different trade-off methods, and we'll let them play that. And you guys just need to know what you value your windows need to meet. The most simple method, I guess, to look at is if you're just trading within the window category. Say you have a fixed window, it performs really well at like 1.2, but the target is 1.4, but you have a casement or a vent window that it performs at 1.6. So your vent window doesn't meet, so now you're like, I'm kind of, this doesn't work, but if you have like a lower percentage of square footage of casement window area versus your fixed window area, which is usually the case, you can do a simple calculation, just sum up the areas covered by each window type, multiply it by their respective U values. And as long as that is below the requirement in this particular case, then you're good to go. So the nice thing about this method is you don't have to get whole new certification. You can use your certification, your stickers on your windows, you're good to go. You just need a little extra math there to make things work if you're gonna go this way. And oftentimes they don't require like an independent reviewer or an engineer to sign off on this. And that's not always the case, but oftentimes that's a calculation that you guys can do. And you can use, you know, your higher performing windows to offset your lower performing windows. So those are the pros. The cons are, as far as if you were to make any changes, say on site, they want a specific glazing type, or they want reinforcement in their windows or something like that, then your stickers can't actually apply. So anything like that, then you would need to get it remodeled again anyway. So it has some limitations there. Another potential con, you could look at it as, say for instance, you have this fancy project and it has massive windows that are way above and beyond what the NFRC size would be. Your U factor that you're reporting for your windows doesn't necessarily reflect that, because your U factor are just this U factors on the stickers. So it doesn't look as great to have, where it could be a lot more impressive, I guess is what I'm saying, if you calculate this specific U factor for those large windows. So that brings us into the performance path, and I'm going to hand the mic back over to John. This is the sandbox that we've been, or should I say, the lane that we've been in for quite a while, and John really helped to develop this side of our business. So,
Thanks, Taylor. We're almost done, guys. And hopefully that we've been at least some help in explaining some of this, and at least getting both your minds around it and appreciation. And certainly we appreciate what you're having to face. So the performance path, that's one name. We see area weighted average. That's another name. There's all, different places, different parts, and different code or regulations. They'll call it something, but it's exactly what intended for what Taylor's saying. Like, we see these type of buildings with giant, windows, huge sliders in West Vancouver overlooking the water, Squamish or Whistler. You want to get that great view. I mean, we're obviously not going to see these in Langley where people can look into my house while I'm changing, but you're going to see these in these high-end homes. And I appreciate it. They're like, why do I have to compete with someone who's just putting small, regular sized windows into a residential home? This also takes into account that a lot of these aren't necessarily residential products. Some of these are like a curtain wall product that's being applied, and an aluminum system that's obviously going to perform poorer than a traditional vinyl or even some fiberglass systems, which also these are in. So it really is designed to allow you to use the actual installed size. And so what we do, and what we've kind of developed, I went to the city of Vancouver, who were the big pushers, and I sat with them. I said, what do you want to see? Like, how do you want these reports to look? And that's actually what kind of started us off at that first early years of doing that. So we still follow the NFRC modeling procedures, and written in both the VBBL and in the newest building code. It's a third party. So an engineer or an NFRC certified modeler is running this and essentially vouching, saying, yes, this meets what's actually installed. So here's just an example of a project that we had, a whole bunch of different windows and doors, had some curtain wall in there, and we basically take the shop drawings or the window schedule, and we find out the width and height of every single product, and we group all the ones that are the same together. We'll have some of these where, like, they have a corner that's SSG, so that's now a new group, one SSG on each, or something like that. So every little variable gets grouped into its own thing. We break it down to an average width and height, and we'd establish, because from that size in each model, we get a U value for each, and it's multiplied by its percentage of area, which then is added together to give you one U factor. What we find most challenging from our perspective is when an architect or even building officials say, I just want to know what the U value is, and or actually even more, the energy auditor, he's like, I just want this U value, and he has no concept of all the information that's going in to get that one number. And the best thing that we try to do with our reports is to make it so that people can walk through and appreciate that this is, an email of like, my U value is this, is actually doing us all a disservice. Ability to walk someone through to see how much information goes into that helps everyone in their industry. So we have these thermal reports. Here's just a few pages from ours. We've got the isotherms, kind of covered up everything, but there's a lot of things that are required to be put in there. You know, specific address, specific project name. We have the actual calculation and the results as well. And so the professional reports or energy compliance reports are kind of have several things. Now, these are not in all of them across the whole country, but these are the top, most consistent. You know, we're providing a professional seal. We're just stating which certification test is current to. If it's you know, we have rated products already, we'll list those in there. A description of each frame, you know, all the IGU type, because you can have a whole bunch of different IGUs in one project, and so that it can give all that information, so someone's not just, you know, getting a printout of that's what it is and don't talk to me and don't worry about it. Getting over that, you know, communication breakdown and frustration that we've seen. And so from our perspective, just to kind of throw ourselves out there, and the same as any other certified simulation lab, so you know one locally or you find someone else, we're all going to need the same thing. So just to start, just to do thermal analysis, we need CAD drawings. I've signed a lot of NDAs because I know that it's important. It's your product. When I'm modeling something, it's yours. At the end of it, if you want all the files I did, if you know what to do with it, happy to give it to you. But I need that because I need the DWG files or DXF in order to actually create the models that go into the NFRC programs. The bill of materials, this is so important. Sometimes I get told like, it's insulation. It's a gasket. I'm like, cool. And it gets to the point where I'm like taking a screenshot of the approved materials. I'm like, just highlight which material because I can't guess. I need to know what it is. It's the best for you is to give the most information I can. The IGU makeup, what's your spacer bar, your air gap, your gas, your widths, and I need those dimensions, especially if we're doing a site specific. To just reiterate, we don't provide labels. So sometimes we get asked, like, can't you just do the modeling and they give me a label? I can't. It's not my role. It's not what I'm permitted to do by NFRC. That's why we had John come up here and take it away. But also just to make the plug, if you're designing a new system, if you're importing a system, if you're want to sell something and you're changing something new and you just kind of want to know what it is, it actually isn't extremely difficult for us to run a thermal analysis. Sure, it is a cost. Absolutely. You know, there's no services in this world are free. Those that are get charged real quick. I mean, we're all paying for parking these days, so soon we paid for breath. But it's a lower cost than going all the way with certification, but at least you know where you're at and know where you're looking to go. When someone approaches us and say, hey, I want to get this certified, I'm not consulting at all. We are now going down this route that like, this is the values. I connect them with an IA, and there's several in Canada. But if if someone's trying to find something out, there's a lot of common things that we know just from years of doing this. And the other thing to reiterate is, Building Code Part 5, even Vancouver Building Bylaw understands that people are going to bring products from Europe. Products are going to come from Asia. And there is allowance for doing a site specific. So you can't use that report and go sell your product anywhere. You're only getting the U value for that location. So it's not like you can't do anything. It's really just a different path. You'll never get to the speed of the Autobahn that you will with certification, but there is a way to continue to produce and work and do what you need to do in order to get projects done, as I said at the beginning, so you can get paid, so we can get paid. And hopefully we've given you a good overview and we'll get you through this to the end.
All right, thanks guys. Anybody got questions for Jonathan? It's all. Use a mic. We got guys online. I just want to make sure people hear you. Sorry.
It kind of goes beyond the scope of the discussion, but I'm curious what your thoughts are on enforcement.
So yeah, that is something that's continually brought up at several meetings. I know in the Lower Mainland, there is consistent push for follow-up. So there's been a few site things. Now, it has only really happened when there's been a problem, I'm being honest with you, but I have seen windows ripped out, 100%. We had a project in Richmond, huge home. I'll tell you, it bankrupted the company. They got repackaged and rebought in a new name, so most of the employees kept going, but it was the end of what was that company. So yeah, it is chasing the tail a little bit. However, I would say a good chunk of the time that I spend, especially because I'm often, presenting and stuff, I'm given reports and asked, is this correct? So the city of Vancouver, if you talk to them, they see our reports the most. There's other guys out there, but like we essentially know when we see yours, we'll do an audit. Obviously, they're not going to just pass it through, but they know what they're looking for. But what they see, all the people working there are kind of our reports the standard, because I met with them what they want. They'll say, hey, we just got this report. Can you double check this? And the reality is that there's about, on a good month, one of those is maybe an issue, but sometimes it's 25% of them. I'm like, this is not really worth the paper it's printed on. So there is a disconnect from final install, except when an issue actually goes wrong. And that is being caught, and that is being penalized, and that is hurting companies. I do know that they're trying to get more boots on the ground to check things. We have tools to check low-E coatings and check gas and performance, and there's thermal cameras and everything. There is a push from energy and mining resources, Cam Shook, right? Yep. Yeah. So COVID hurt that initiative to get that going. They were pushing for something in 2019. It's happening, but it's going to be slow, and obviously we're going to see it first on the West Coast. So,
yeah, just to add to that, you're talking about the City of Vancouver. City of Vancouver has its own building bylaw and also their own energy performance requirements that are very aggressive, probably the most aggressive in Canada. Yeah. And they've done a very good job of enforcing that, unless you're offside. They make it very public when they do rip windows out of buildings, and they've done that on multiple occasions. So what we saw when the City of Vancouver first brought in their new energy performance requirements a number of years ago, it was a 1.44 U value. And it didn't take long to find out that they were enforcing it and pulling product. And you saw very quickly that the compliance went way up.
Way up.
Because it got out that was being enforced. People knew what was going on. They were following the letter of the law. So, compliance is such a challenge that poor enforcement just leads to, poor compliance. I mean, nobody's enforcing. So, I've always been a real supporter of the City of Vancouver because they put out aggressive targets and then they back it up, which, that's great. That's what they should be doing. And
they've also been really good. I mean, January 1st of this year, it went to 1.22 for all windows and sliding doors. Hinge doors are 1.8. And 1.80. So 1.22 and 1.80. And, but that wasn't like, you didn't wake up January 1st and you're like, oh my gosh, obviously my clients, we have a long relationship with, they value what we give, they value the way that we interact with them. And so they knew it was coming up. What happened on January 3rd was, the lower half is calling me and they're like, oh my gosh, how do I get this to pass? And I'm like, this was known for a long time. And so I say there is some definite proactive attitude that needs to happen from our side, from our industry, but people can choose to be blind. The city was not a big surprise. That was years in the making.
Yeah, and the thing with the City of Vancouver is they brought that in on January the 1st, permit date. Yeah. So anybody that knows the City of Vancouver, you get a permit and you build a house 2 years later. So there's plenty of notice of what that's going to do to the industry. So yeah, they're doing a great job.
Yeah, and that's what Taylor's multicolored chart actually shows. Different provinces are like, okay, we'll adopt this, and yeah, it's an older standard, but sure, it'd be nice we're all on the same page. But I think even the provinces know, man, if we just jump to whatever current, we'll just kill our industry in our province. So that's why it's delayed in different requirements in other areas. So.
Jonathon, I was at the Passive House conference in Victoria a couple of weeks ago, and that movement is growing, particularly in the West. But I was having some conversations with Rob Bernhardt there, and he was telling me that Toronto is really ramping up their Passive House activity. There's going to be significant funding to do Passive House renovations in multi-unit buildings. But I don't think we've seen a lot of Passive House certified components in Ontario or in central Canada, as opposed to what's in BC. Do you think that that's truly going to be sort of that next step for window manufacturers to have a Passive House certified product?
Well, I'll speak on two sides, and Taylor, you can jump in, correct me, or or add to that at the end. So I actually had a meeting with the city of Vancouver. Brady fought. Thank you. And I actually have one when I get back to talk about this specifically, because generally what we see is, these push to be green, and Passive House done an amazing marketing job. Like Energy Star I thought was amazing on marketing. Passive House is just schooling them how to do it. And so you have energy auditors who have in their mind, like, solar heat gain is free energy. We want to get the highest solar heat gain we can and the lowest U value. There's limitations, especially when we model it to our standards. And I know Al's going to speak on that tomorrow. So make sure you come for that, because I've seen a portion of that presentation. It's eye opening, and it lets me know where the industry is needs to be more educated. But when I met with Brady, he said, yeah, we're told City of Vancouver, and we're shown, hey, Passive House is great. And we kind of, made the Vancouver bylaw to get about to the same values where Passive House is going. So they should be okay. I said, Brady, you need to recognize something. And this is something that we are not doing good enough of doing, is telling people that Passive House windows are designed for Passive House buildings. It is a full building assembly. Your walls are different, your roofs are different. So just to put in a window and call it a Passive House window and it hits everything, but keep everything else standard, you actually are not, providing what you're saying you're providing. It's not the same thing. And energy models are struggling with that, because they're like, well, why? I just saw one recently. He wanted a 0.94 U value and a 0.55 solar heat gain. There is no triple glazed product than any rated system that I know of. And I've been I showed them tons of glass options. I'm like, on a triple glazed with 3 low E coatings, the best I can get you is a 0.32. And they're like, but I could get it with Passive House. I'm like, I appreciate that. And you built a Passive House certified house, go ahead and use those. If you're not building that, you're sticking to NFRC and CSA standards. So that's the first thing. The second thing is, we are not doing a good job at being proactive. So when Vancouver comes out and says 1.22, or they announce they're going to do it 3 years in the making, there's this huge groan from the industry. And, we can't do that. Why would you make us do it? You're going to kill our industry. Well, to be totally honest with you, when I went to Germany, I went and met the guys at Passive House, and I was like, wow, this is great. And they showed me all their products, and they got a cold room and you hold your window up. I'm like, wow, this is the new future. And then I go out of the city that they're in, and they're like, oh, we dumped Passive House 5 years ago. So there's hunger over there for any market that will welcome them with open arms. They will chew us apart if we don't be proactive to what the standards want, because they'll fly in and there's confusion and unknown. And they'll be like, oh, well, look at our products. We're amazing. We're so much better than what you can even get in North America. So we have to do a better job of going to code officials, researching building codes. I mean, even just call me or email me and say, help me understand markets I'm selling in and what I need to do, so that we're educating the people who are getting those numbers, saying Passive House is great. It is, as long as you're doing a Passive House building. Once you're outside that realm, these are what the values you have. So that's what I think. Yeah.
Can I just add a couple of quick comments? I don't know how long ago, about 10 years ago, maybe, a really good guy out of Ottawa wrote an article about how the perceived superior performance of European windows was wrong. And I think we Canadian manufacturers, for the most part, if I may call it that, are a little naive about some of the things that are going on, because the things that the Europeans put into their numbers, their calculations, they are defined by the European systems, partly temperatures, materials that they don't use, that they will penalize as a result. And it goes across in many different ways. And I think, to his point, I think our industry needs to be way more aggressive in how we do this. It really pisses me off as a Canadian window manufacturer, how we are kind of shown as these incompetent people. We make triple pane low E windows. Yeah, the gaps are slightly different things like this, but they propose it as if a U with an umlaut on it makes it a superior window. It's such bullshit. And we need to get way better at this. I have no qualms about us shooting for better levels for whatever reasons, whether you want to believe in resource mindfulness or environmentalism or anything. To me, it's good for our industry. We can do great things with what we do. But I think we have to sharpen up in how we do things and not let them run us over with a U with an umlaut.
I just want to, yeah, thanks, Al. I just want to comment to your comment, Jonathan, about the industry groaned. When Vancouver brought in the 1.44 U value, it essentially killed the sliding window in Vancouver. Now, today, there's multiple manufacturers in southern BC building sliding windows under 144, and some of them crowding 1.22. So, they're pushing and the industry is responding. Like Al says, we need to respond quicker though. This is coming, to think that these changes are not going to happen and we're not going to be driven to these better performing products is naive. So I think we need to get to it.
Yeah, to that point, when I took my passive house training, it was taught by a German guy who has dyed-in-the-wool passive house, and he's, when talking about windows, we asked, okay, well, who around here sells these windows? And he's like, oh, no, you can't get these windows in North America. You have to import. This is not a German accent, by the way. I don't know why, but he was of the opinion, and obviously he's training all the passive house people that these windows do not exist in North America. Now, this is a couple years ago, but it is sad that they have that opinion. But like I said, it's really looking at the numbers. It's not better or worse. It's just different. And but to get those passive house numbers, it's a whole different modeling methodology, right? And so. So to report the U value with the little passive house flare on that, then you have to go through the passive house modeling procedure. So it is a challenge. I don't know if it's worth getting your Windows passive house certified, so then where you stand on that front. But that it is a good point that it's something that more people are becoming aware of.
The government needs to step up. Is that on? To step up and help manufacturers get there, though. Again, in British Columbia, a few years ago, there was a program called ICE, Innovative Clean Energy, and they actually funded manufacturers to develop either passive house or Energy Star most efficient products. And we saw a real spike of those products being available in that market because of that. My former life, we launched 2 passive house systems that were funded partially by that, and it was a reasonable amount. Like it made it attractive to go after that. So government, they need to help manufacturers come up with these new products and help them in the cost, because we're still fighting in a relatively small market when we talk about high performance window and door systems. So help us build them, and then everybody's building high performance. Well, now the industry and all the houses are getting high performance products. So government needs to step in and help much more than they do today.
Totally. There is often, because it's a new thing, and oh my gosh, there's a requirement, and here's just my paperwork. Like if you're in that realm and you're getting RFIs back from inspectors or everything, you need to understand that what you're really doing is leaving the door open for passive house or other people to come in and bring product they say is great and it meets and it's certified and they have all this stuff to walk through. The best we can do is operate both on completion and on education. So from my standpoint, if you've got your team and you're like, hey guys, like we need to understand what this is, I'm educated as I've done this, but whatever, a solar heat gain and U value, that's what we report. But they want some background information so they can talk to building officials. I'm happy to do that. I do a lot of Zoom seminars for companies. So, email me, ask me, but really it's presenting the information so clearly that the city knows and the regulatory bodies know what they're receiving and what you can do. When the city of Vancouver first says we want to be the greenest energy, they listened to industry. Industry came back and said, this is what we can do. This is what we're at, and we're willing, or we can get to here. I know that city of Vancouver wants to go further down, but they brought it to 1.22 to allow the industry to adjust. So they will listen to you. I know that for sure. And it's really just a proactive approach to educate as well as, make sure that we're all getting product done, sold out, installed, and moved on. So,
Any other questions? I knew I could count.
Yeah, you always can. So, on one hand, you've got the relative ease and convenience of having a label on the product that the building inspector can understand and all the rest of it. On the other hand, you've got the possibility of doing different things with your design. This is more from the contractor's perspective, of doing performance path stuff and being able to mix and match your systems and arrive at the values. So everything's getting tighter. The standards in all the provinces, right? It's getting more and more demands on the energy performance of the house. What's your prediction as far as where the builders are going to end up going on the prescriptive versus the performance path stuff? Because I was at a building science conference just a little while ago, and I can tell you there's a lot of enthusiasm among the contractors for going performance path on stuff and being more on that side of it.
So you want to speak on that? I'll tell you my experience and then you take it, but I'll be brief. So in Vancouver, which I'll start there, we have this step code, and it's really like it's designed for the trade-off method. Like Taylor had mentioned, you can have, better wall assemblies, then your U values don't have to be that good. That sounds great, and we do it, and we do it every day of the week. But from contractors, a lot of them, especially general contractors, are like, just tell me the threshold. Like, what is the number I have to hit? So there is a little bit of disservice on the upfront of them just expecting, I just want X. I think it really will benefit us to, each of you, when you go to meet with a general contractor and you have your window package, you can say, here's the prescriptive method, or here's what this area is required, and here is my performance data and how to get that. Because if you can just show them it passes, they're confident. I mean, all too often I'm getting calls from the site who's like, I got a building inspector coming in a week. My labels don't match my the threshold. Vancouver 1.22. I got labels. This is actually back when it was 1.44. I had a slider that was 1.68. Are they going to rip this slider out? And I'm like, no, I've already completed the U value performance path for that. Call the window supplier. And then I'm like, why didn't the window supplier just connect with the general contractor in the first place and just say, hey, my stickers don't match what the threshold number is, but here's how you know, so that they're confident going to the building officials. So that's what it is for me. Taylor, on that?
Yeah, I think, and talking to a lot of the code officers, the guys that are writing these recent revisions of the code, the performance path is what really excites them. So it seems like that's what they want to push people towards, but it's a more costly and drawn out process, right? But maybe that's what excites them about it. I don't know. But it is funny how there's, the code writers have a different vision of what is awesome than the GCs and the architects in some instances.
The performance path should actually excite most window manufacturers. My experience dealing with the BC step code, performance path, what was happening is we were seeing buildings looking for high performance windows, triple glaze oftentimes, because the cost upgrade to that window was less than upgrading the walls or the roof or the slab insulation or the HVAC system. So in fact, as we move into this path of performance, high performance windows are going to become very attractive to builders because they offset so many other costs in the building. It'll be easier to sell. Yeah. It'll be easier to sell a high performance window for sure.
Yeah. Yeah, and as we've seen with the Passive House, it's marketing. It's spending some effort and teaching them what they're looking for, and that is open to us. Now, I know we're getting short time. I hope to meet everybody. I hope to get you one of our coveted limited edition Layton Consulting pens. Love to help you on that. And even on if you have your stuff already certified, we've done a lot of helping our clients figure out how to do their trade-off method so that they can do it themselves, so they can provide that information themselves. So there's different ways in which that we could serve you and make sure that it's as most efficient as possible. So just happy to help
Last
with that.
chance for a question. 9 minutes to lunch. Thanks for coming all the way from
Thanks,
the
Terry.
west, gentlemen. Appreciate it. Really enjoyed that. Great information. Thanks a bunch.